Including conditional statements in your Grasshopper definition can be a useful technique when you're calculating or analyzing certain things and you need to determine if the values that you've calculated fit a certain criteria. We can use the components here in maths operators, larger than and smaller than, as well as some of the logic gates that we have here to establish those conditions. What I'd like to do is I want to take the surface that I have here in Rhino. I want to populate it with many points, and I want to generate three groups of points. The points that are highest, the points that are in the middle, and the points that are the lowest. We'll use these logic operators to do that. First, let's bring in our surface, params, geometry, and surface. Let's right-click in the center, set one surface, and select surface we have in Rhino. I'll turn off the preview. I need to populate this with a bunch of points. If I go to Surface, Utilities, we have Divide Surface. Plug the surface in there, and actually I'd like some more points than that. Let's put a panel here and control the number of points in U and V. Double click, quotation, I'll put in 30. Should be enough points for now. Let's plug that into U and into V. I think that's just fine. What we're actually going to be checking is the height of the points. And to do that, we need to actually decompose the points that we have here so that we can see the z. So I'm going to go to Vector, Point, Deconstruct. Now we have our z values. Let's focus on the first group, the highest points. Here we should check if the height is higher than some value. I'm going to go to Maths, Operators, Larger Than. I'll plug in the z to a. Is z larger than some value? Let's plug in a slider. This slider I'll make here on the canvas. I'll double click, type in 0 to 20. What I'm actually going to get out of this component is just a set of true and false values. Let's see what this looks like. If I go to Params, Input and Panel, I see that I already have some trues. I have some falses. Is the point height higher than 0? Well, I have some points on the edges that are actually at 0. We're probably going to get false. It's not higher than, it's exactly the same. If I switch to greater than or equal, those turn to true. For now, we're just focused on those values, those points that are higher than 0. As I start to change this, probably our list here of what's true and false is going to be changing as well. And if I go all the way up to 20, maybe I have some points that do go beyond 20, but for the most part, most of the points should be under that. As you notice, here we have true and false values. What can I do with these values? We saw previously that we can actually use sets, sequence, and call pattern. This time, though, the pattern is coming from this condition. I'm going to plug in my points into L, and now I'll plug in the result of the condition into the pattern. As you can see, with what I have selected, only the topmost points get selected. Is the height higher than 11? If it's true, we'll see it here. If it's false, it just gets thrown away. We're not dispatching, so we're not keeping the false values. Let me delete my panel. To make this a little bit clearer, so I don't always have to select it, I'm going to go to Display, Preview, and Custom Preview. I'll do a color there, params, input, color swatch. White is just fine for now. So that's easy enough. We have a slider, and we can change the condition by changing the value. So now what if I want to get the middle points, so the points that are below this, but higher than some other value? We need to start with checking if the point is below this value that I have here. Let's go to Maths, Operators, Smaller Than. Z gets plugged into A, into B I'll plug in the same slider. Now these are true and false based on this value. If the points are smaller or lower than this value, then it's going to be true. But I don't want it just to be the rest of the points. I want this to be higher as well than some other value. So let's go ahead and bring down Maths, Operators, Larger Than. Plug in our Z into A. This time we need a new slider. I'll go ahead and copy this one. Bring the value down, plug that into B. Is the point higher than 7 but lower than 13? Now we have a situation where we have two conditions. We need to test if both of these conditions are true. If both of these conditions are true, I should get a new band of points in the middle. How can we combine these? If you recall Boolean logic and how it is described with Venn diagrams, here in Maths Operators, we can use these logic gates and eventually set that up. So I'm going to use gate and. If this is true and this is true, then the result is going to be true. Let's see if that worked. I'll copy this and I'll plug in my second result into the pattern. Let me change the color. These points that we see highlighted here in magenta now are lower than my first slider value, but higher than my second slider value. And of course, you can control this and always dynamically modify that set of points. Let's finish this off and return the final points. These are the points that are lower than my second number. Let's go to Math, Operators, and Smaller than. I'm going to connect z into a and my second value into b. Here I don't need to check any other condition. It's just, is it lower than this value? I'm going to connect this to the call pattern. Let's copy these, plug our pattern into p, change the color. These are effectively the rest of the points, anything lower than our second value. In this way, we can continue to be testing conditions and filtering our lists. This is a useful technique for many different operations, especially different ways that you can set up conditions and split off data based on if the data meets that criteria or not.